Okay, dear students, so let's start our class. Today, we will discuss first about the inequalities on real quadratic expressions. After that, we'll start discussing about the theory of, polynomial equations of a degree more than 2. That means degree 3 or higher order, higher degrees polynomial that we are going to discuss, and the relevant topics related to that. So, before I start, as usual, what I do, please make sure that you are able to uh, hear my voice clearly, dear students. Very well.
Yes, sir.
Okay. And just I'm going to just please confirm that you are also able to, view the digital screen properly.
Yes, sir.
Yes, sir.
Okay, great. Thank you very much for your confirmation. So, what we're going to discuss, as I said, the first we'll discuss about the inequalities on real quadratic expression. So, what is about that? Whenever we say that ax square plus bx plus c equal to 0, that becomes an, you know, quadratic equation. Correct, no? When you write ax square plus bx plus c equal to 0, then we can say this is a quadratic equation. Now, from here, what we can write? We can write fx equal to 0, where fx equal to ax square plus bx plus c. Now, this one, that fx equal to ax square plus bx plus c, this is known as the quadratic expression. Means, if you give different values of x, you will get different values of fx, correct or not, of this expression. So that is known as the quadratic expression. Now, the moment you say that fx equal to 0, this is an quadratic equation. This is an quadratic equation. Okay. And when you say fx equal to this, only ax square plus bx plus c, and that we know as a quadratic expression. So, dear students, what we are going to do here, we are going to discuss about the inequalities on this real quadratic expression. And here you will see, obviously, one statement you are aware of, that a is greater than 0 and abc belongs to R. That is obvious. And here you will see that two terms, one is that a, that is coefficient of x square, and another one is d, that is the discriminant, dear students, that is b square minus 4ac. This plays a major role in the computation of these linear inequalities. So what I was saying is that, as you know, that a, b, and c, this belongs to the set of real numbers, and a is not equal to 0. Obviously, if a is equal to 0, you know that this equation doesn't become this equation, or that relevant expression doesn't become a quadratic one. It reduces to a linear one. And the d is what? As you know, the discriminant b square minus 4ac. We will see that a and d plays a major role in finding that one. How it is, that we are going to discuss now. So, dear students, that let me first tell you the expression, that about the whatever I said, that let me tell you in the form of an equation, in the form of a statement. Here is the statement. The expression fx equal to ax square plus bx plus c, where a, b, c belongs to R and a is not equal to 0, is known as a real quadratic expression. Let b is equal to b square minus 4ac. And we can now get the following results on the value of the quadratic expression fx. Okay. interesting one. So first one is that the first case what we are going to discuss is that, a is greater than 0 and d is less than 0. So what happened, as I said, dear students, that if I write in a different color, a and d plays a major role here. So one thing can be possible is that a is greater than 0. When a is greater than 0, okay, so if I write like this, we can write a could be either greater than 0 or less than 0. When a is greater than 0, there are three cases possible. One case is, one case what is possible is that d is, less than 0. Another case is, let me write it here, dear students. So from here, when a is greater than 0, from here we can get three set of values of, d. Okay. So first set is that d is less than 0, d is less than 0, d is equal to 0, and d is greater than 0. And when a is less than 0, okay, then also for d you will get three things. One is less than 0, one is equal to 0, and one is greater than 0. So these are the entire branching, dear students. So when a greater than 0, there are three sets of values of x, that is d less than 0, d equal to 0, and d greater than 0. In the similar manner, when a is less than 0, we get three set of values of d, that is d is less than 0, d is equal to 0, and d is greater than 0. And we need to, take care of each and every case. The first case, what we are going to consider is that when a is greater than 0 and d is less than 0, then one thing for sure, dear students, that the value of fx will be always, greater than 0. The first thing, as you see, when a is greater than 0 and d is greater than 0, d is less than 0, what we can say is that the fx is always greater than 0 for all x belongs to R. Second case, what is coming, dear students, is that when a is greater than 0 but d is less than 0, when a is greater than 0 and d is equal to 0, what we are going to get? We are going to get is that fx is, greater than 0 except for the point minus b by 2a. That means fx is greater than 0 for all real number except the value minus b by 2a. And at the point minus b by 2a, what is the value? The value is equal to 0. Correct? So we cover all the cases here, that when, as long as the set of real numbers is concerned. Now the third case, when a greater than 0, is that a greater than 0 and d greater than 0. So what we can say here, a greater than 0 and d greater than 0, we conclude something like this, that when a greater than 0 and d greater than 0, we get the following results. What is that? First one is that f alpha equal to 0 is equal to f beta. That means alpha and beta are the roots of the corresponding quadratic equation fx equal to 0. And we are assuming alpha is less than beta. So first what we get, f alpha equal to 0 equal to f beta. Fx equal to 0 for all x minus infinite to alpha union beta to infinite. And fx is less than 0 in between alpha and beta. That means what? If I write in a number line representation, if we draw a number line representation, this is the number line, and this is, it goes to plus infinite, this goes to minus infinite, this is the origin, okay, that is the point 0. Origin means 0 point. So we are assuming alpha is less than beta. So let's take, this is alpha and this is beta. So what we see is that alpha, f alpha is equal to 0 is equal to f beta. Okay, and between 0 between alpha and beta, fx is less than 0. Okay, so if we draw a curve, it will be something like this. We can draw a curve also. I wanted to discuss all these things, during our parabola discussion. So if you see, the curve is something like this. Correct, na, dear students? Let me draw it properly. The curve is something like this. This is, fx, y equal to fx curve, you can say. If you look into it, if alpha is 0, that is the x-axis, if you can assume, if alpha equal to 0 equal to f beta, correct, na, dear students? And when between alpha and beta, what we get? The fx is less than 0 below the x-axis, if we assume this as x-axis. Right? Na? If you take the origin and as a, and if we consider, just a minute, let me complete drawing the axis. Okay. This is the y-axis, y dash, and you can consider this as x-axis, x dash. Then this is the way we are going to conclude. When between alpha and beta, what we get is that fx is less than 0. When it is from minus infinite to alpha and beta to infinite, it is actually, you see, the curve is above the x-axis. That's why fx is greater than 0. And at the 2 points alpha and beta, fx is equal to 0. All of you will be able to understand very clearly, dear students, from this graph. Graph is nothing but a visual representation. But what you need to remember the points what I wrote in the left-hand side. Okay. In fact, for the case when a is equal greater than 0 and d is equal to 0, then also you can draw a graph like this. Okay. What it will be, in this case, if I draw a different color, for this representation, show what it will be. If I draw in a small, just a minute. Whenever I start drawing the straight line in the digital board, I face problem. So this is x-axis. X-axis you can assume also as a number line. This is y-axis, y, o, y dash. So what kind of curve it is, This curve, if I draw in a different color, the curve is something like this. This is y equal to fx. That is y equal to fx. If you see, at all the points, fx is greater than 0, except at minus b by 2a. This is the point minus b by 2a, where it is actually touching the x-axis, and hence the value of fx at that point is 0. I hope you understood.
Yes.
Correct, no?
Yes.
Okay. Now, if you look into the previous case also, you can draw a graph for that. If you look into this case, you can draw a graph for this case also. If this is the x-axis or the number line, the way you want to define it, and this is the origin, this is y, this is y-axis. Okay. So fx is always greater than 0. That means what? It is something like this. Let me draw in a different color. It is something like this. Y equal to fx, correct or not? So when we get that fx is always greater than 0, in the second case we see that fx is greater than 0 in all the cases except minus b by 2a. And the third case what we get, dear students, is that fx is 0 at 2 points alpha and beta. Between minus infinite to alpha, it is greater than 0. Again, it is greater than 0 from beta to infinite. Between alpha and beta, it is actually less than 0. I repeat, dear students, the graph is nothing but a visual representation of whatever I wrote in the inequalities. Okay. Sometimes it is important as well when you discuss about coordinate geometry, but from a pure algebraic point of view, you need to remember these points. Now, so what we have done so far, dear students, we are able to cover this part. If you see, we are able to cover this region when a is greater than 0, correct? Na? Now we are going to cover when a is less than 0 in all these three cases, how it is going to be, that we are going to discuss now. Correct, dear students? So the first point what we're going to discuss is that when a is less than 0 and d is less than 0. When a is less than 0 and d is less than 0, how it looks like. When a is less than 0 and d is less than 0, fx is always less than 0. Fx is always less than 0. So how to represent this in graphical representation? So graphical representation will be something like this. If this is your, x-axis or the number line, the way you want to define, and this is your y-axis. Y, this is origin, this is y dash, this is x, o, x dash. Then what we are going to get? Fx is less than 0. If I draw in a different color, so the curve will be something like this. Y equal to fx. Correct, no, dear students? Clear? The second point, what is coming is that I think it is very clear. There is no doubt here. Second point is that when a is less than 0 and d is equal to 0. You can make a proper analogy of the previous case. Okay. So when a is less than 0 and d is equal to 0. So we get what? We get that fx is less than 0 for all real number except minus b by 2. And at the point minus b by 2, what is the value? The value of that function, that expression is equal to 0. Okay. So how to represent that one? So let me first draw the coordinate axis. Okay. Okay. And the curve will be something like this. I draw it properly. Okay. So if you see that this curve y equal to fx is less than 0 for all real number except that minus b by 2. Any issue at any point, please feel free to ask me. Then the third case, dear students, is that when that a is less than 0 and d is greater than 0. When a is less than 0 and d is greater than 0, then how we are going to do it? That we are going to look it now. When a is less than 0 and d is greater than 0. So for the corresponding polynomial equation, that is fx equal to 0, if we have two roots alpha and beta, and if we assume that alpha is less than beta, then first we are going to get that f alpha equal to 0 is equal to f beta. And the second point is that fx is less than 0 for all x belongs to minus infinite to alpha and beta to infinite. And between alpha and beta, fx is greater than 0. Now all these three statements, if you give a visual representation by means of a graph, so it will be looks like something. This is x-axis, this is y-axis, and our curve will be something like this, where this point is alpha and this point is beta. Alpha is less than beta because if you can consider that xo exists as a number line as well. And if you see from minus infinite to alpha and from beta to infinite, fx is below the curve is below the x-axis. That means the value is less than 0. And above the x-axis, you see that is between alpha and beta, where you see that fx is greater than 0. That is a proper visual representation of whatever the statements I wrote in the left hand side, dear students. So we also covered this part. So you need to remember this thing and the visual representation also, but more than visual representation, as long as the inequalities are concerned, you need to memorize so that you can apply accordingly. And we'll, as I repeat the statement, that when you'll discuss about that, coordinate geometry, then all these things will again come into the picture. Correct, dear students? So this is all about the inequalities with the quadratic, expression. Now, what we are going to do, the theory of polynomial equations, where the degree of third and higher degrees and the relationship between their roots. Okay, so what is meant by that? So let me first pull that one, that note. Let me show it to you, and let me start in a new page. So what we are going to do first, dear students, is that theory of polynomial equations of third and higher degrees. Okay, because second degree though we have already learned. Okay, that is the quadratic equation. But that knowledge of quadratic equation, okay, we are going to apply in the third and fourth degree also, and higher degrees also, and you will see that how it looks like. The first thing what we are going to discuss is that let's define what is a polynomial equation. Let us first define the polynomial equation. So, a polynomial equation, I hope, dear students, you agree to me by now that a polynomial equation will be looks like something like this. The equation a0 into x power n plus a1 into x power n minus 1 plus a2 x power n minus 2, in that way up to an equal to 0, is a polynomial equation where ai belongs to R, means all ai, means a0, a1, a2 up to an all belongs to R, and a0 is not equal to 0. Because if a0 is equal to 0, then the equation no longer become a quadratic equation. Correct, na? It reduces to sorry, I'm so sorry what I said in the last few seconds. If a0 is equal to 0, then the equation no longer become a polynomial equation of degree n. It reduces to a polynomial equation of degree n minus 1. Correct? So now, as you know, it is a polynomial equation of degree n. It has n roots, real or complex. Correct, dear students? So it has n roots, real or complex. Now, how we are going to do when we are dealing with a cubic equation? Let us see. So let us take a cubic equation, something like this, and let me help you understand. So let me take a cubic equation. Suppose we take a cubic equation like ax cube. Let me use a different color, dear students. So let me take a cubic equation like ax cube plus bx square plus cx plus d equal to 0. Now, how many roots it has? It has 3 roots, as you know. Okay, because it is a cubic equation. Let us assume the roots are alpha, beta, and gamma. Let alpha, beta, gamma be the roots of, okay, be the roots. Then dear students, what we are going to have? Alpha plus beta plus gamma, that should be equal to what that should be equal to minus of coefficient of x square by coefficient of x cube, that is minus b by a. So sum of the roots. The next point is that it is the sum of the roots taken 2 at a time. That means what? Alpha beta plus beta gamma plus gamma alpha. Correct, dear students? Taking 2 at a time. So then what it will be? This will be equal to c by a, that is coefficient of x divided by coefficient of x cube. And then we take 3 at a time, that is alpha into beta into gamma. That should be equal to, dear students, is that minus of constant term divided by the coefficient of x cube, that is a. Why I wrote like this thing? Look for a pattern. First it is minus, which is there, then plus, then minus. Similarly, if you recall our quadratic equation, if I just quickly write it here, dear students, that ax square plus bx plus c is equal to 0, it has how many roots? 2 roots, alpha and beta. So how we found alpha plus beta? Minus b by a. And what we find alpha into beta? Then after minus it become plus c by a. Correct, not dear students? So when you take three, roots of a cubic equation, and then we find that sum of the roots taken two at a time, and the product of the all the three roots. This is the pattern we need to follow. Okay. So if I write in a very note-wise manner, so how we can write like this? So it is something what I'm going to write is that for a cubic equation ax cube plus bx square plus cx plus d equal to 0, okay, whose roots are alpha, beta, gamma. Either all the three roots are real or one root is real and the other two roots are complex conjugate. We need to understand this point, dear students. So what is the equation we are considering? Ax cube plus bx square plus cx plus d equal to 0. Now what are the possibilities? It can have either all the three real roots, correct or not? It can have three real roots. Now another possibility is that you may think, sir, can it have one complex root and two real root? No, not possible. Why no, dear students? Because complex root always comes in conjugate pair. Always. Suppose someone is telling, hey, I have a polynomial equation. One root is 2 plus 3i. Can you say something? You can first say, I can tell you the another root. It is 2 minus 3i. Definitely. So it is impossible to have, you have only one complex root of a polynomial equation. If it is possible that no complex root is there, but if complex root is there, it has to be 2 or 4 or 6 like that. Always conjugate pair should be there. So it can have one real plus, sorry, let me write properly, one real root plus two complex root. Correct, no? It is impossible to have three complex roots again. Why? Because complex roots comes in conjugate pair. So if two roots you can conjugate pair, then third root is conjugate to whom? Not, right? So this is a very important piece of information, dear students. So whenever you deal with polynomial equation, when the concept of complex root is coming into the picture, then always you should assume that, not assume, it is a rule that complex roots always comes in conjugate pair. So for a cubic equation like this, you can have either all the three roots are real or one real root, two complex root which are conjugate to each other. And here I mentioned, dear students, that sum of the roots S1 is equal to sigma alpha. That is a symbolic representation, sigma alpha. That is nothing but alpha plus beta plus gamma, that is equal to minus b by a. Then S2, that is the sum of the products of the roots taken two at a time. That is symbolic representation is equal to sigma alpha beta. That means actually alpha beta plus beta gamma plus gamma alpha. That is equal to c by a. And then it comes the S3, the product of the roots, that is equal to alpha beta gamma, that is equal to minus d by a. Okay, so this same pattern actually follows for the biquadratic equation also. So for a biquadratic equation means what? Equation, polynomial equation of degree 4. It will have four roots, alpha, beta, gamma, delta. There also you can find alpha plus beta plus gamma plus delta. Then also you can find that, taken two at a time. That is alpha, beta plus beta, gamma plus gamma alpha like this. Similarly, you can get taken three at a time, alpha, beta, gamma plus alpha, beta, delta plus alpha, gamma, delta plus beta, gamma, delta like this. And taken four at a time, alpha, beta, gamma, delta. Same pattern you need to follow, dear students. Okay. So now what we are going to discuss is that means, if I write this thing, whatever I just said in in the last 1 minute is something like this. As you see, dear students, so you can also verify this thing. If we have our equation is that ax is cube plus ax power 4 plus bx cube plus cx square plus dx plus e. Note into this particular point, and if it has 4 roots alpha, beta, gamma, delta, then what is summation of alpha? That is alpha plus beta plus gamma plus delta, that is equal to minus b by a. Then taken 2 at a time, alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta. You can make all this permutation here, taken 2 at a time. Correct, not dear students? When you make 2 at a time, then it is alpha beta, means from alpha beta gamma delta, you are taking 2 at a time. Okay. Uh, I made a little wrong statement. It is a combination. It is not permutation, because the moment you take alpha beta, you should not take beta alpha. Correct, no? So alpha beta, then alpha gamma plus alpha delta, like this. You understood? So, and then you can take 3 at a time. That is S3 alpha beta gamma. Okay, that is minus d by a, and taken 4 at a time, alpha beta gamma delta is like this. And this formula can be generalized to equation in the nth degree. That means if you have a polynomial equation of degree n, and you know the n roots, that is alpha 1, alpha 2, alpha 3 up to alpha n, then you can find what is the summation of all these roots, that is equal to minus of coefficient of x to the power n minus 1 divided by coefficient of x power n. Correct, not dear students? Okay. Okay. Now what we're going to do is that, as we understood the relationship between the roots and coefficients, okay, with quadratic equation, cubic equation, and biquadratic equation, generally in your at your level, in both in board examination and in entrance examination, it is not likely to that you are getting an equation to deal with the roots and coefficient of degree of polynomial equation of degree more than 4. It is quite unlikely. So now what we are going to do, dear students, we are going to solve problem together. Couple of problems we are going to solve together. What is that? The find the sum. First question I'm going to give you, and all of us will do. Okay, please open your notebook and we'll do together. And you will find it interesting to solve, because the questions comes in entrance examination and board also to some extent, from applying these concepts, where you need to apply the concepts of relationship between the roots and coefficients. What is the question here, dear students? Find the sum of the squares of the squares and the cubes of the roots of the equation x cube minus px square plus qx minus r equal to 0. So sometimes you see, dear students, all these parts are, that background, there is some, it is actually the watermark, which I take the portion from my, study material, and I'm showing to here. That's why this, background images you see. But let's not concentrate on that, only concentrate on that equation. What is the equation here, dear students? X cube minus px square plus qx minus r equal to 0. And what is the question? Question is that find the sum of the squares and the sum of the cubes of the roots of the equation. So let alpha, beta, gamma be the roots of the equation. How to solve it? Let alpha, beta, and gamma be the roots of the equation. What is the equation here? X cube minus px square plus qx minus r equal to 0. Then, if you recall, dear students, the relationship between the roots and coefficient, so what we are going to get? alpha plus beta plus gamma. What will be alpha plus beta plus gamma, dear students? Can
P.
someone please say? Very good. It is P. Absolutely correct. And what is alpha beta plus beta gamma plus gamma alpha?
Minus Q.
Are you sure?
Uh, no, so yeah. Uh, uh,
It is minus Q or Q?
Q. Will be Q.
It will be Q. Correct.
Q.
Why? Let's go back to our understanding. When you take two at a time, dear students, alpha beta plus beta gamma plus gamma alpha, that is equal to gamma alpha, that is equal to C by A.
Yes.
Correct, na? So
Yes.
how it goes? Minus plus like that. But first one is minus because minus of minus P, na? Actually, what you can write here is that this is equal to minus of minus P by 1. Correct or not?
Mm.
That's why it get P.
Mm.
After that, it will become plus. And then alpha into beta into gamma, what it will be? It will be equal to, can you please say?
R.
R, exactly. So now, what you need to find? We need to find alpha square plus beta square plus gamma square, isn't it?
Mm.
According to the question, we need to find alpha square plus beta square plus gamma square. So now it is an obvious requirement that we need to express this one, that is this expression, that alpha square plus beta square plus gamma square, in terms of alpha plus beta plus gamma and alpha beta beta gamma gamma alpha. Because why so? Because we know their values. So now we need to go back our mind to our class 9 standard, whatever we have learned, a plus b plus c whole square or a square plus b square plus c square, if you recall, dear students. So that will be what? This is equal to alpha plus beta plus gamma whole square minus 2 into alpha beta plus beta gamma plus gamma alpha. Correct, no? So this implies what? This implies alpha square plus beta square. You see the previous knowledge of algebra, how it is coming into the picture here. Alpha plus beta plus gamma is what? P. So it should be P square. And minus alpha beta plus beta gamma plus gamma alpha is what? Q. So P square minus 2Q. So that's why you get the value of alpha square plus beta square plus gamma square. Absolutely clear or not?
Yes.
Now, the next question is what? Next question, you need to find the, sum of the cubes of these roots. Means alpha cube plus beta cube plus gamma cube. Alpha cube plus beta cube plus gamma cube. How you can do it? You can think of that a cube plus b cube plus c cube, that formula you can apply.
Minus
Or
3.
you can think something, different approach. Okay. And we need to always think that whatever we have achieved, how we can leverage that one to find our solution. So let me do in a different color, dear students, so that you can make a difference later when you follow this class note. So dear students, one thing is that alpha is the root of this equation, na? Alpha is the root of this equation, x cube minus px square plus qx minus r equal to 0. As alpha is the root of this equation, definitely it will get satisfied by alpha. So what we are going to get? Alpha cube minus p into alpha square plus q into alpha minus r equal to 0. Correct or not? So from here what we get? We get alpha cube is equal to p into alpha square minus q into alpha plus r. In the same manner, what we will get? Beta cube we will get p into beta square minus q into beta plus r, and gamma cube is equal to p into gamma square minus q into gamma plus r. Correct, na? So now what we are going to do? Let us add all these things. In fact, I can take it here. So if you take all these things here, dear students, what you are going to get? P alpha square minus Q alpha plus R plus P beta square minus Q beta plus R plus P gamma square minus Q gamma plus R. So simply you can take P common, what we get? Alpha square plus beta square plus gamma square, isn't it? Then minus Q into alpha plus beta plus gamma. Correct or not? And plus R plus R plus R, that is plus 3R. So what we are getting? Alpha square plus beta plus gamma square, you already found it out. That is P square minus 2Q. Minus Q into alpha plus beta plus gamma, we already found this as P. Correct, na? Plus 3R. So what we are going to get? We are going to get that is equal to P cube minus 2P cube minus P cube. So minus 3P cube plus 3R. So that is the value of alpha q plus beta q plus gamma q. That is the most efficient way we are able to find it out. Clear now, dear students? Okay, great. Now the next point, what we are going to discuss, dear student, another problem. So, and I want you to solve it, and please, the way I said, open your notebook and do along with me. In fact, I can give you some time so that you can do, and then we will discuss. Okay. So the question is something like this, and I want you to solve it. Please take a couple of minutes to solve it, and then we'll discuss. So the question here is that if alpha, beta, gamma are the roots of 7x cube minus x minus 2 equal to 0, find the value of summation of alpha by beta plus beta by alpha. As you are new to the sigma, uh, symbol, what it says is that means, dear students, what? Let me use a different color. This means what? This means is that you take, all the combinations of alpha, beta, gamma. Okay. So that actually literally means this is equal to alpha by beta plus beta by alpha plus after alpha, beta, what is come? Beta, gamma plus beta by gamma plus gamma by beta plus what is coming? Gamma by alpha plus alpha by gamma. It actually symbolically means about this thing. Got it, na? So you need to find the value of this expression. You need to find the value of this expression, that is alpha by beta plus beta by alpha plus beta by gamma plus gamma by beta plus gamma by alpha plus alpha by gamma. Subject to the condition is that alpha, beta, gamma are the roots of the equation 7x cube minus x minus 2 equal to 0. So obviously, dear students, one thing to pretty clear is that we need to use the relationship between the roots and coefficient, correct or not? Okay, so I suggest you to please spend 2 minutes to solve it, and then we'll come back. Any progress, dear students?
Sir, I'm getting -3.
Fantastic. That is indeed a correct answer. Appreciate. Okay. All of you got -3, dear students?
Yes, even I got -3.
You got -3? Great. So let's see how we are going to get it. Okay. Good. Appreciate. So how to proceed this one? So we need to find that alpha by beta plus beta by alpha plus beta by gamma, like this. So how we are going to write it down, dear students, is that, if we find the, first we need to find the sum of the roots, no? If you find the sum of the roots, so what we are going to get? We are going to get it is 0, correct or not? Because the coefficient of x square is 0. So this is the way I solved it. If you find any better way, please do let me know. So, what you see, dear students, here is that alpha plus beta plus gamma, that is sigma alpha, is equal to 0. Then sigma alpha beta is equal to -1/7. And alpha beta gamma is equal to 2/7. That is we are getting from the roots and coefficient. Now, what is alpha by beta plus beta by alpha summation over alpha by beta plus beta alpha means? It means this thing, alpha by beta plus beta by alpha plus beta by gamma plus gamma by beta plus gamma by alpha plus alpha by gamma. Now we are just little rearranging. We are writing alpha by beta plus alpha by gamma. Then one alpha by alpha we are adding. So we are subtracting that alpha by alpha also. Same thing we are doing with beta. Beta by alpha is already there. Beta by gamma is already there. We added beta by gamma, beta by beta, and also subtracted that one. Correct, no? And similarly, gamma by alpha is there. Gamma by beta is there. Gamma by gamma is not there. So we added it and we subtracted it. Similarly, this for alpha by alpha, no, dear students. So after that, what we are doing, if you look into these first three terms, we can take alpha plus beta plus gamma common. Correct or not? Then what we get? 1 by alpha plus 1 by beta plus 1 by gamma. Correct or not? And -3. Because alpha by alpha is 1, beta by beta is 1, gamma by gamma is 1. So it is 3. Now what is alpha plus beta plus gamma? This value is 0, na? So finally we get the value as -3. Clear or not clear? So this is the second example what we have done. So the next point what I would like to discuss, and that is a very interesting thing, and that will help you to understand that a polynomial equation of degree n, how many positive roots it is having or how many negative roots it is having. Okay, and that is known as the Descart rule of sign, and that is the topic for the discussion for today, and that is the last topic for today. So what is Descart rule of sign, dear students? That we are going to discuss now. So the Descart rule of signs tells that, let's first now consider a polynomial equation of degree n. So if we take the polynomial equation of degree n, so it looks like this. Let fx equal to fx is a a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 up to an is equal to 0, where a0 is not equal to 0 be a polynomial equation of degree n, where ai belongs to R and I values from 0 to n. Now the Descart rule of sign tells what dear students. It is very simple thing, but very effective in calculation. It tells very simple thing. It tells 2 points. First point, it says that the number of positive roots of the equation fx equal to 0. The number of positive roots of the equation fx equal to 0 is less or equal to the number of changes of the sign in the coefficient of the polynomial expression fx. If less, then it is less by an even number. Let us understand. Then you will able to understand that value of this English statement very properly. Let us take an equation is that suppose 7x power 5, 7x power 5 plus 3x power 4 minus 4x power 3 plus 2x cube minus 3x minus 8 equal to 0. Descart rule of sign is going to help you to find how many positive root it can have maximum. Means by applying the Descart rule of sign, we can say that what is the maximum number of positive roots this equation is having. Okay, how to find it out? Let's see what is the coefficient sign. Coefficient sign, dear students, here is that sign of 7 is what? Plus. Let me use a different color. Sign of 7 is plus, correct, na? Then sign of 3 is plus, sign of 4 is minus, sign of 2 is plus, sign of 3 is minus, and sign of 8 is minus. So plus to plus, there is no sign change, nothing is going to happen. Plus to minus, there is a sign change, so we add 1. Minus to plus, there is a sign change, we add 1. Plus to minus sign change, we add 1. Minus to minus sign change, there is nothing. So it can have maximum of 3 positive roots, or if it is less than 3, then it should be less than by an even number. That means it can have either 3 positive roots or 1 positive root. Got it, dear students? Now let us get back to the statement. If the number of positive roots of the equation fx equal to 0 is less or equal to the number of changes of sign in the coefficient of the polynomial expression fx. That's what we have done it here. If less, then it is less by an even number. Correct? So this is the way we can find what is the maximum number of positive roots this equation is going to have. In the same manner, we can find what is the maximum number of negative roots this equation is having. So for that, let's first assume what is fx. Fx equal to 7x power 5 plus 3x power 4 minus 4x cube plus, here it will be 2x square plus 2x square minus 3x minus 8, correct? So first we'll find what is f of minus x. Dear student, f of minus x will be minus 7x power 5 plus 3x power 4 plus 4x to the power 3 plus 2x square plus 3x minus 8. Now let us see what are the sign changes in the f of minus x. It is coefficient of 7 is minus 7 is minus 1, no, not coefficient, sign of minus 7 is minus, then plus 3 is plus, then plus 4 is plus, then plus 2 is plus, then plus 3 is plus, then minus 8 is minus. So minus to plus, there is a sign change, so plus 1. Plus to plus, no sign change, no sign change, no sign change, then there is a sign change, that is plus. So we can say this equation, that equation means this equation actually, or the original equation, this equation equal to the fx equal to 0 can have maximum of 2 negative roots. Or if it is lesser than that, it should be lesser by an even number. That means what we can say, it can have maximum of 2 negative roots or 0 negative root. No negative root at all. And if you now go back to the statement, it says this thing, the number of negative roots of the equation fx equal to 0 is less or equal to the number of changes of the sign in the coefficient of the polynomial f of minus x. If less, it is less by an even number. Okay, dear students, with this, I'd like to conclude the class for today. Okay, tomorrow we'll be discussing something very interesting, and that is about some important result, on the roots of a polynomial equation, and that will be very effective to solve problems for entrance examination. Thank you very much, and we'll again connect tomorrow.
Yes.